This is a walkthrough of problem 2 on exam 1 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 2, a double slit experiment is performed with a laser, has a wavelength of 628 nanometers. The screen is 150 centimeters away from the slits. The fringes on the screen are 1.75 millimeters apart. What is the spacing between the two slits? So let's focus on the central maximum and the first maximum above the central maximum. So let's draw these two lines. This is an exaggeration of the angle. The angle's much smaller than this. The bottom red line goes straight across to the central maximum. The red line a little bit higher than that is the first maximum above the central maximum. And that's a distance of 1.75 centimeters on the screen. That's a horizontal distance of 150 centimeters. It's a very good approximation for this angle. We can write tangent theta is 1.75 millimeters, the distance between the two bright fringes on the screen, and 150 centimeters, the distance from the slits to the screen. Getting the same units there, we can calculate the angle, 0.0668 degrees, a very small angle, exaggerated significantly in that diagram. The path difference between those two is one wavelength because it's the first maximum. In order to really see what's going on, to get D, we have to zoom in on the slits to see what's going on. So here are the two slits. This is R1, this is R2, there's slit 1, there's slit 2. This is the angle we just calculated. There's a line straight across to the central maximum. This is the line going up to the first maximum. This, of course, is exaggerating significantly so we can see it. This is the line that makes an isosceles triangle. These two angles are the same and they're virtually 90 degrees because the lines are almost parallel. Here is the path difference. We calculated that theta previously, 0.0668 degrees. The path difference is right here, and it's one wavelength. The angle theta is also right here. It's the same triangle. 628 nanometers is this distance. We can write sine of this angle is the opposite side, 628 nanometers, divided by the hypotenuse. The hypotenuse is what we want, the distance between the slits. We have the angle, so we can calculate D. There's the angle. We substitute that in. We get D in nanometers. That's 0.538 millimeters, about a half a millimeter. Let's call it 0.54 millimeters. That's the answer to problem 2.